All right, here is number 3. So the modulus would be the square root of square root of 2 squared plus square root of 2 squared. So that would be 2 plus 2, which is 4, which is 2. And then the angle, if we go over and up the same amount, isn't that angle just pi fourths? See how sometimes you don't even need to worry about doing the inverse tangent because you could just graph it and figure out the angle. So this would be the inverse tangent of square root of 2 over square root of 2, which is the inverse tangent of 1, which is pi fourths, which is why I said I did it the way I did so that you could then add your own paper if needed. Okay, so then we have our z is 2 cosine I sine of pi fourths. We are doing cubed roots, so n equals 3 and k will equal 0, 1, and 2. So we're going to go w sub k is equal to the cubed root of 2 times the cosine plus I sine of pi fourths divided by 3 plus pi 2 pi divided by 3 times k. So that would be pi 12ths plus 2 pi thirds k, right? Okay, so I just simplified that part of it. So w sub 0 is going to be the cubed root of 2 times the cosine plus I sine of pi 12. And then w1 is going to be the cubed root of 2 times the cosine I sine of pi 12ths plus 2 pi thirds. So let's multiply that by 4 to get a common denominator. So 8 pi 12ths plus 1 is 9 pi 12ths. That 9 pi 12ths would reduce to 3 pi 4ths. And then the last root would be the cubed root of 2 times the cosine I sine of pi 12ths plus 4 pi thirds. So that would be, here I'm going to write this out, pi 12ths plus k is 2, right? So that's going to change this to 4 pi thirds, which is 16 pi 12ths. So that would be 17 pi 12ths, which is not bigger than 2 pi. So we can theoretically leave that. Cubed root of 2 is the cosine times I sine of 17 pi 12. So here's root 3, root 2, root 1, and you can always change those to rectangular form. Oh, but would I want to change this to rectangular form? It's pi 12. The only one we would actually know the exact number for would be this one. So. All right,